So we were working on H2O, and for H2O, we have moles of H2O right now because our grams of H2O cancel out. And what we want is moles of H, and in every 1 mole of H2O, there are 2 moles of hydrogen. So we'll solve for that now. .5309 divided by 18.02 times 2. I get 0.0589. Moles of hydrogen. And then multiply that by 1.008 to get the grams of hydrogen. And the grams of hydrogen are almost always the same as the moles because it's almost 1, just a little tiny bit higher. We do have nitrogen in here, and let's do nitrogen next. It's on the same sample size though, which makes things pretty straightforward, I think. Take the 0.0688 grams of nitrogen, and since it's all nitrogen, those are the grams of nitrogen as well. But we'll do it the formal way. In nitrogen, there are 2 N's. That's 28.02 grams of nitrogen per 1 mole of nitrogen, N2. And then in 1 mole of N2, there are 2 moles of nitrogen. So 0.0688 divided by 28.02 times 2, I get 0.00491. Moles of nitrogen. And when I multiply that times 14.01, I get my 0.0688, which I started with. So because it was all nitrogen, we were counting them 2 at a time. All we did by doing this calculation was start counting them 1 at a time to get the proper number of moles. Now we have to find oxygen. The only way to find oxygen is to start with your sample, subtract off, I lost my color coding there. Subtract off nitrogen grams, hydrogen grams, and nitrogen grams. Minus 0.472 grams of carbon, minus the grams of hydrogen, minus our grams of nitrogen. And let's see if we have anything left. We have 0.6 minus 0.472 minus 0.0594 minus 0.0688. And this time we get minus 0.0002 grams of oxygen, which is clearly not correct because mass cannot be negative. We did not just discover antimatter or antimass. And this number is so much smaller than all the other numbers that it's telling us that there's no oxygen in the compound. Oh, yes. There is no oxygen in the compounds, and our formula is just going to be C something, H something, N something. Are there any questions about that, how I figured that out? I think we talked about this before. If not, I meant to. If not, then let's gather things up. I like to gather things up down here and say C and my moles of C, 0.0393, H, 0.0589, N, 0.00491, and then divide by the smallest number, which is the 0.00491. And instead of writing it out, I'll just do it here. But I'm doing it to all of them. And my N gets a 1. My carbon, 0.0393 divided by 0.00491 is 8. My hydrogen, is 12. And this is my empirical formula. That's not what they're asking for. So they're asking for the chemical formula, which you should find is the molecular formula. We know that the molar mass is 244. For the empirical formula, let's now find the empirical formula's molar mass. To do that, we know that it's 8 times 12.01 plus 12 times 1.008 plus 14.01. We get something at 122, or 122.19 to be precise. Can anybody tell me what we have to do to get from empirical formula to molecular formula? Knowing that the molecular formula has a molar mass of 244 grams per mole.
Don't you have to multiply? Divide it.
So we've covered both parts of it there, I think. Thank you. So we're going to divide these two numbers to get the factor that we then need to multiply this times to get the molecular formula. So the way I would say it is molecular formula divided by empirical formula is going to be the 2.
Factor is 2.
Yes, it is 2. And I'll write it out here. And again, you don't have to show this work if you know it. You can just multiply it times 2. But this number is 2. And so that means that 2 times our formula is going to equal C16, H24, and 2. And that is our molecular formula. So yes, I think, thank you. Times 2, however you get there, and it's not always this clear, so it's nice to show this process.
I had a similar question, but my value, what I was getting was too high. It was just off. And I followed the same exact procedure, so I don't know what.
Is this, sorry, I can't see who this is talking, but so you had something for the similar to the 0 grams of oxygen?
No, I didn't. I had a value for 0.0152 moles of oxygen. That was what I got when I subtracted it.
Yeah, so go ahead.
And that was the lowest, so I used that value to divide the rest of them. And for carbon, I got 29.5. For hydrogen, I got 41.6. For nitrogen, 1. And for oxygen, 4.
Yeah, actually, that one works. That is, I bet the answer for that is C29, H41, NO4. That is a possibility. So go ahead and try that.
Okay. So since I got 29.5, there was no point timesing it by 2 to even out the half.
No, what happens is when the numbers get that big, you can go back, and if you look at these numbers, see how they all have, well, this one has 4 sig figs and 4 decimal places. So if you carry one more sig fig, I bet those work out exactly.
Okay.
Yeah.
Thank you.
But yeah, right. That's an interesting question. And then Manal, I had similar question with 0 grams of nitrogen, and I'm not getting the molar mass. So with 0 grams of nitrogen, that means there's no nitrogen in the compound. And it is possible that there's no nitrogen or oxygen, so you'd have to figure that part out too. And I'm happy to take a look at your work and let you know what's going on with the problem. Um, so yeah, so there's a bunch of variations on this. Um, any other questions? But this is the whole approach to this right here in this problem. There we go. Okay.
Hold on, sir.
Question?
I need to take a picture of the
Oh,
page.
I think that's as much, yeah, that's pretty much everything I can get on the page, which I think is pretty much everything. Did you get it?
No. Okay, can you bring it down a little bit?
I won't be